Hi guys, greetings of the day. This is Vijay Tavardhan. Welcome back to my YouTube channel for learning a subject called as Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on the bell icon to receive the latest video lectures as and when it is going to be uploaded in my YouTube channel. Now let's start the session number 7, which is with respect to the filters and strainers. The graphical representation is as shown in the figure over here, which is called as filters. The performance efficiency and service life of the hydraulic system depends on the precision of components used. It is not just sufficient that if the components are used of high precision and accuracy, the same precision and accuracy should be maintained throughout the device of the service period in the hydraulic components. By definition, a filter is a device whose primary function is retention of insoluble contaminations from the fluids by some porous medium and strainer. In simple words, a filter or strainer is a device whose function is to trap insoluble contaminations contained in the flowing fluid, and a porous medium simply refers to the screen of filtering material that allows the fluid to flow through it, but it stops the material. And the graphic representation is as shown in the figure on the right hand side. You can see that. Then coming to the types of filters, filters are mediums in an hydraulic system used and arrest unwanted materials reaching or getting into the system and purify the oils to achieve the best performance for the hydraulic system. Hence, the filters are the most important part of the hydraulic system in particular and any fluid power system in general. And the different types of filters which are going to be broadly classified into three types based on the following factors. They are method of filtering, size of the porous in the filtering material, and then location of filter. Coming to the first type of filtering, that is called as method of filtering, there are three types of methods of adopted in the hydraulic systems. They are, first one is called as mechanical filters. In mechanical method, metal or cloth screen or a series of metal discs separated by a thin spacers are used. This method is capable of removing only relatively coarse particles from the fluid because the solid contaminations are physically arrested, and it is called as mechanical filter. Then come to absorption filters. Absorption filters use porous and permeable materials such as paper, pulp, cloth, cellulose, asbestos as filtering medium. In this type, the particles are actually absorbed as the fluid penetrates the material. These filters are used for extremely small particular filtration. Coming to adsorbent filters, adsorption is a surface phenomenon and refers to the tendency or affinity of the particles clinging to the surface of the filter medium. And filter medium include activated clay, chemically treated paper. The capacity of such filters depends on the effective surface area of the filter medium which is available. Then coming to the sizes of the pores in the material, there are two types of filters based on the size of pores in the material. They are, one is called as surface filter, the another one is called as depth filter. What is called as surface filter? Surface filters are nothing but simple screens used to clean oil passing through their pores. The screen thickness is very thin and dirty. Unwanted particles are collected at the top of the surface of the screen when the oil passes through it. The example is strainer. Coming to depth filters, depth filters contains thick wall filter, medium undesirable foreign particles. Much foreign particles are arrested and the capacity is much higher than the surface filters. And the figure shows the dirt holding capacity of the surface as well as depth filters again is the pressure. Then coming to the sub-classification of the surface filter, which is called as full flow filter. And what is called as full flow filter? The necessity arises in some of the hydraulic system that the complete oil must enter the filter element and its inlet side and must be expelled out through the outlet after crossing the filter element fully. In case full filtration, the size of the filter is so designed to accommodate the entire flow at that part of the circuit. This is obviously efficient in terms of filtration, but incurs large pressure drop. This pressure drop increases as the gas filter gets blocked by contamination. Generally, these filters are provided with the safe valve before it, which cracks when the filter is unexpectedly blocked. Then coming to the one more type of filter that is called as bypass filter. In some hydraulic system application, only a portion of oil is passed through the filter instead of the entire volume, and the main flow is directly passed without the filtration through the restricted passage or venturi. As the main flow passes through a venturi, a localized low pressure is created, and this pressure difference across the filter influences the filter to draw the proportion of the fluid through the filter, and hence the proportional flow filter is also called as bypass filter. Then coming to the location of filter, the various locations are used to arrange a filter either in return line or in the pressure line, or each having its own advantages and disadvantages. And in general, the following are the preferred locations: primarily the intake or inline filter, then pressure line filter, then return line filter. And the figure shows the different types of filters. Coming to intake or inlet filters, inline filters are provided just before the pump to protect the pump against contamination in the oil. These filters must be designed to give a low pressure drop, otherwise the pump will not be able to draw the fluid from the tank. To achieve the low pressure drop, the filters a coarse mesh is used. Coming to pressure line filters are placed immediately after the pump to protect the valves and actuators, and can be of finer and smaller mesh. They should be able to withstand the full system pressure, and the most filters which are used in hydraulic system is of pressure line filters. Then coming to return line filters, the return line filters are those which filter the oil returning from the pressure relief valve or from the system, that is actuated to the tank. It is placed before the tank. They may have relatively high pressure drop and hence can be of fine mesh. And these filters have to withstand the low pressure only to protect the tank and the pump from the contamination. Then coming to gases in hydraulic fluids and its effects and filter performance, we are going to discuss now. Then the gases in the hydraulic fluids and its effect, very often in the hydraulic oil may create undesirable of the system. The gases or air can be present in the hydraulic fluid in three forms: primarily free air and entrained gas and free air. And what is called as free air? The air can be present in the free pockets located in some high point of the hydraulic system, such as highest elevation given pipeline. And catastrophic failure of the system component if the free air is contained in the hydraulic fluid operating at higher pressures enters the region of low pressure. And this sudden expansion of air may damage the related parts. And coming to entrained gas. Entrained gas is nothing but the gas bubbles within the hydraulic fluid. These are generated or created in two ways. Flowing fluid sweeping the free air from air pockets and carrying the same along with the fluid stream, and due to the pressure drop in the pressure of the fluid below the vapor pressure. Then coming to dissolved air. As mentioned, air may be present in the fluid from free solution to free state conditions, continuously changing the state with the change of pressure. Fluid received at atmospheric pressure typically contains about 6% of dissolved air by volume. After the fluid is pumped, the amount of dissolved air increases about 10%. Then coming to pump cavitation, the pump cavitation can be eliminated by maintaining the suction pressure above the vapor pressure of the fluid. And this can be achieved by controlling the speed of the fluid, having a short section line, then coming to fever settings and proper design of the reservoir, and maintaining the temperature of the fluid as recommended. Coming to the filter performance, filter is one of the most important element of the hydraulic system, which plays a very important role in enhancing the operational efficiency of the hydraulic system. And the very purpose of the filter in the hydraulic system is to arrest or eliminate the undesirable elements in the fluid, which may exist both in the solid and liquid form, and clean the oil. Then several important factors needs to be considered for selecting the correct type of filters, and some of them are given here. They are minimum particle size to be arrested or trapped, and the quantity or weight of the particles to be trapped or held, and the flow rate capacity, pressure rating, then pressure drop across the filter, filter compatibility with the system medium, and filter condition indicator provided. And a filter is a device which retains or traps insoluble contaminants from the fluid using the porous medium, and a strainer of coarse filter. And the filter efficiency is going to be determined as per the ISO standards of 16889 multi-pass test procedure. So by this, I'm going to cut down the session till here only. Thanks for your patience for the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in the session. Don't forget to like, share and subscribe. Have a great day. Signing off, Vijay Tavardhan. Thank you.